our presentation will focus on the practicalities really of how do we measure the ROI of Industry 4.0 project, technologies such as IoT and AI. Our main message today is really, it's not about the technology, it's how do we bring business value in today's industry and especially today's environment. And really our hope here is to share information, share some of our lessons learned in the industry. As a company, we are a software provider. We provide solutions to the industry around manufacturing, automation, and optimization. You see here some of our customers, from very big OEMs to the smallest suppliers and globally. Very proud to work with partners such as Siemens or Vertec in the industry, and of course with the CTC in Stade and the AMRC in Sheffield. So we're really doing a lot of activities in composites industry, and I hope I can share our experience here today. There are three topics I'd like to cover. First, a bit of a background. Why are we doing this? What is the opportunity? Then I will go more specifically, again, from our own experience about measuring the ROI and what we're trying to do. And we will share a brief case study with some further information. So, what is the problem? If everything was perfect, then there's nothing to optimize. But of course, the reality today is quite different. When we see factories, again, from the largest to the smallest, and from East Asia to the United States and Europe, of course, we see very common problems. At the root of it, in many cases, we see production systems and processes that were developed 5, sometimes even 10 years ago, that are simply not able to deal with the complexities and the volumes that we have today. Disconnected systems, a lot of data, a lot of manual touch points, and these typically lead to excess waste. You'd like to be here with economies of scale. In many cases, we see a collapse in process and waste. The good news here is that there's opportunity, and this opportunity is often quantifiable, which is a key message today. Even if we look beyond the composites industry, and it's important to put here context, we're seeing more and more evidence that this technology applied correctly drives a lot of impact, whether it's around throughput or productivity, whether it's around cost reductions in materials or OEE, etc. These are areas that are there to improve, and more evidence in composites and beyond are showing that. This is a report by McKinsey and the World Economic Forum. Specifically, we're all here virtual and not in Paris in March, but it's very clear today there is an accelerated understanding that into adoption of digital transformation and digital technologies. We see initiatives that were planned for years happening overnight, over a number of months. And the guiding question that we'd like to offer is, where to start, how to do it. Because if you're going in the wrong direction, it doesn't matter how fast you do it, you won't end up where you'd like to be. So taking a step into the details, what does it mean to have a connected factory? There's a lot of discussion on data collection. We'll talk about that. We want data. We want it in real time. We want to analyze the data. But really the end goal here is to optimize and automate the process. We want to drive efficiencies. So this is the end goal, and everything else needs to be a means to that end. So, we go out there and we meet a lot of companies, and in many cases, they ask us where to start. And our answer is start where it hurts. What is the business problem you're trying to solve? Are you trying to solve costs, material waste? Are you trying to increase your productivity? Are you trying to improve your quality? In many cases, we see companies that skip this stage. They run straight to the technology, and they're not doing themselves a lot of favor. So really, our message today and the best tip we can offer is start with the problem you're trying to solve, prioritize them, and only then seek the technology to solve it. And now you've identified your problem and you want to solve it. And then there's a lot of discussion about data and data integration. If you look at industry journals, there's an abundance of data and discussion of concepts like IoT. Where we see many companies fail is they try to get too much data. They try to get all. This is actually quite a problematic endeavor. You want to get the relevant data. Get the data that you need to solve the problem, not more and not less. And this data will come from three main sources. First of all, the enterprise system, the PLM, MES, ERP, of course, they have a lot of data. Today, it's not utilized. Machines and sensors, they create more and more data, and there's certainly a lot to capture. And in our industries, let's not forget the users, the production team. They have a lot of knowledge and a lot of data that is often not collected by machines or sensors, and we should certainly leverage that channel as well. So we know which problem we want to solve, we know what data we need, the relevant one, and we know where to get it. Now, what do you do with the data? You need to put it to use. And again, there are three steps here. They're incremental, and they also present greater and greater value. The first question you need to answer on the production floor is, what is happening now? What is the status of my production floor? There are different algorithms for that. The next question is, what is going to happen? Where are we heading? Predicting bottlenecks, failures, quality issues, delays. And here, of course, if you predict something good, everything's on track, there's nothing to do. But if you predict a problem, you certainly want to alert and to solve for it. And then comes the highest layer of optimization and AI capabilities, is the ability to solve the problem. Instead of just telling someone that they have a problem, you want to help them solve it. The professional term is prescriptive analytics. And of course, this calls for another set of tools. But if you're able to implement all three layers, you will achieve a lot of value. Even if you start with one and gradually add the second and the third, that is certainly a viable road. Let me emphasize this concept from the consumer world, and this is an example I use a lot. On the right, you see the navigation app Waze. We all use it, or most of us use it quite often. And it really helps us to drive. It connects to traffic information, it calculates how to drive from A to B, and it tells us what to do. On the left, you see a dashboard. This is also by Waze. You're welcome to their website and type any city. This is Paris. And this gives you color indications about traffic situation, etc. Many companies have dashboards. They're quite useful, but they're limited. They're limited in the sense that if you're now watching this, you need to understand what you're looking at. You need to look at it all day. And eventually, if you need to drive from point A to point B, you need to solve the problem. So there's a lot of human intelligence here, but certainly the value proposition on the right is much higher. If we are able to implement these tools on the production floor, they will certainly create more value than those on the left. So let's take a step in and start talking about the ROI of such a system. The first concept I'd like to introduce today is what we call a POV, proof of value. And again, this really centers the discussion around the business proposition and not the technical proposition. POCs typically focus on the technical proof of concept. Does this technology work? It's an important question, but the better question to ask is, how does this technology help me with my business goals? What am I trying to achieve? What are the KPIs? Let's design the pilot program around the value proposition. In most cases today, especially if the vendor or technology are more mature, you can go to some other site or research organization and see the technology. The more important question is the impact on your day-to-day work and financials. If you look around and you read industry research, and this is our experience as well, we see impact typically in three main categories. The first, from left to right, are what we call the top-line benefits: productivity improvement, rework reduction, more flexible or faster time to market. The second is around cost savings, bottom-line savings, production cost reductions, inventory reductions, to an extent labor savings, although they will be less dominant. And of course, there's risk reduction that comes from digitization, quality issues, full traceability, and the like. So if you're aiming for such a project, your goals are probably in one of these buckets. Just make sure they are well articulated and aligned with your business goals. In terms of cost, it's actually pretty straightforward. We see most companies do a pretty good job here. You know, what is the cost of the hardware, the software, the deployment, longer term costs such as maintenance, etc. Nothing much to add here. Just keep in mind all these elements. They typically fall well within spending templates of your organizations. This is the easy part. The more interesting question, and here we're seeing more and more layers of benefits, are the value proposition. What does the system do for me? And here perhaps to share some of our lessons learned in doing so. The first one is that it's quite easy to capture direct benefits, but you need to be looking beyond that into what we call here indirect benefits, because they can be even higher. If you're able to save material on a given part or product, that's great. But if you're using less material per product, this typically also trickles down to your overall inventory and inventory holding costs. So make sure to capture them as well. What does it mean to have a delayed delivery? There's not just the direct cost of the fine. What does it mean for the organization? How much time is spent and at what level to deal with this problem? The second insight we have is actually surprising in many cases to many people. There's a lot of focus on reducing manual touch points, and everybody is rushing to measure the labor savings. What we're seeing is that the labor savings are actually secondary, and I'll show that in the example. The real value comes from the mistakes that people make, or the prevention of mistakes. They create quality issues, rework, production delays, and if you do the math and you put dollar or euro signs around it, you will see that the direct savings are actually not as important. When you do these projects, I really recommend to reevaluate a lot of the given assumptions that you do in production. We see this a lot. You have or may have a lot of inventory or buffers on your production floor. Why do you do that? Because you always did, because before you did not have an Industry 4.0 system. Sometimes we see cases where there are just too many tools, sometimes twice as much as needed. Why? Because they do not have a good system for maintenance, so they just bought more tools. Too many quality checks, etc., etc. A lot of this can now go away, simply because you don't need them anymore, because another element, whether it's a hardware, robotics, or software, was able to replace them. And last, perhaps, many people overlook this hidden gem. Whatever you're implementing now is replacing something else. And this something else typically has a lot of maintenance costs to them, whether it's a services fee to another organization, internal costs, and the like. Certainly, I would pull these into the ROI. So a quick case study. This is actually a tier 2 supplier, a commercial supplier, and they set out around 3 metrics. They want to increase their throughput, reduce their rework, and reduce their raw material scrap, cost reduction, classic one. The POV process went over 5 weeks. It was well-defined and well-planned. The questions, the operational questions that were discussed were around, the material monitoring, the allocation of materials to the job, taking into account all the factors. How do you track the kit made from this material all through the curing process? How do we know for sure that the job will be completed before a material expires? So the scope of the system was around tracking the materials and kits with sensors, generating alerts on projected failures or delays, and also allowing the warehouse team to pick the right material and for the right job at the right time, based on the demand, based on the availability, the shelf life remaining, and so forth. The sensor network that was deployed, again, were deployed to enable the system, not anything else. So it was, again, very accurate, very cost-effective, and a design to solve that problem, of course, with the ability to extend it and scale it up. You see here an example of the alert based on past production behavior and patterns, based on historical data, based on the current situation. The example here predicts a production delay. And if there's a production delay, it may put the material shelf life at risk. And if that's at risk, the entire part may end up in scrap. So the alert here is to accelerate this part, or perhaps put it back in the freezer. The optimization example is the selection of materials, of the thousands of materials in this case that are in a given warehouse, which are the right ones for a given job. The operator gets a simple pick list. If you remember the Waze example, they get instructions. For job number 1, take material number 10. For job number 2, take materials number 11 and 12, etc. This is in the hands of the production team. They pick the materials, the sensors pick it up, and the materials are then sent to the floor. To wrap up this point, here's a quick analysis of the value proposition, of the outcome. This is already calculated based on the assumptions from this manufacturer. And you see here 4 main categories. One is the reduction of rework and the related quality issues. This accounts for a significant amount. The second is simply saving raw material even before they become part. The third is the indirect savings from reducing the inventory holding costs. And the fourth is actually around labor savings, but as you can see, it is a rather small portion of this pie. And this is typically where we find it. So quite substantial savings for this supplier, well quantified and well measured in a proper POV. So in summary, we are seeing across the industry more and more use cases where these technologies address business pains. The implementation must focus on the business value, not on the technical value. We do see and recommend for you to seek both top and bottom line savings. And there are methods to quantify them in advance of the system deployment. Just to leave you with this cartoon, I actually found it very relevant. Take a look. And again, this goes back to our points about elevating data, not just to dashboards, but actually to actionable insights. So as you glance over this, allow me to pause here and finish, and thank you. And if there are any questions, I'm very happy to take them.
Thank you, Avner. There is no question from the audience right now, maybe later on. It was really interesting to see that human factor is still the most important thing to cope with. No, not the technical aspect. And how do you cope with the reluctancy of people to implement this kind of solution?
Yeah, it's a great question. It's really a big part of our day-to-day activity. First of all, our philosophy is that there's a man-machine team to build here. We do not see the software or the hardware doing a better job on its own, unless it's a very singular or point solution. And it does come with improvements. So we see this team working together as our goal. And what you will see is that if this is implemented properly, then this team does a better job than the software alone or the user. And in terms of trust, this is something you need to earn over time. If the system does a good job, produces quality recommendations, the users will learn to trust it. Quite similar to how we learn to trust our digital assistants in our life as consumers, again, going back to the travel navigation app.